Hi, welcome to this STAIR Tailored. My name is Sarah Powell and I work at the University of Texas at Austin. And today we're going to use algebra tiles to solve one-step equations that feature an addition operator symbol. And by addition operator symbol, I mean that these equations all have a plus sign in them. So we're going to first look at x plus 2 equals 5, and then we're going to look at 6 equals x plus 4. Let's go ahead and get started. So with these algebra tiles, these are available for purchase. You can also probably just make some paper copies of these. But with these algebra tiles, today we're going to be using these rods and units. I'm going to kind of move these around just like this. You'll notice that these rods can flip over. They have a green side and a red side. The green is going to represent our positive x, and the red side will represent any time we have a negative x. Then we have these units, and you'll notice that the units can be flipped over. They have kind of like a tan side and a red side. The tan side is going to represent a positive 1, and the red side will represent a negative 1. So let's go ahead and use these algebra tiles to set up this equation right here. So we start with x. That is a positive x, so I'm going to go ahead and bring in my positive rod. And to that we're adding 2. That is positive 2, so I'll go ahead and bring in 2 tan units just like that. Now on the other side of the equal sign, we have 5, and that is also a positive 5. So I'll kind of quickly, as I can grab them, bring in positive 5 units like that. So here, if I'm just looking at this problem, and I even cover this up, I don't even have to see it, I see that I have x plus 2 equals 5. So now let's solve this problem. We solve this problem by isolating the variable. That means that I need to remove this constant, and I can use 0 pairs to make that happen. I want to remove this constant so that this side of the equal sign equals 0. So if I bring in 2 negative, that will create 2 0 pairs. That brings that side to equal 0. But whatever we do to one side of the equal sign, we also have to do to the other. So here, I now have this set up, so I'm going to create my 0 pairs. There's a 0 pair, there's a 0 pair. I also see some 0 pairs on that side of the equal sign. So x equals 3. Now let's go ahead and solve this next problem. We start with 6, and that 6 is positive. So I'll go ahead and bring in 6 positive units on this side of the equal sign. Now on that side of the equal sign, we have x, and that's a positive x, plus 4. I'll go ahead and bring in my 4 units just like that. We want to isolate this variable, and we do that by creating 0 pairs. I need to bring in 4 negative units to create 4 0 pairs. But remember, whatever I do on that side of the equal sign, we also have to do on this side of the equal sign. So here I also have to bring in 4 negative to create 4 0 pairs like that. Now kind of quickly, I want to show how this matches the notation. If I'm solving this equation, I usually draw a little line down from the equal sign. And here I'm going to remove the constant by subtracting 4. And remember, I do that from both sides of the equation. Get that set up there just like that. Look at what we've done with our manipulatives. This exactly mirrors the abstract procedure that we use to solve this problem. So here I have x plus 4 minus 4, and here I have 6 minus 4, all right? So we know that this side will end up equaling 0, and why is that? It's because I can create 1, 2, 3, 4 0 pairs. And here on this side, I can also create 1, 2, 3, 4 0 pairs. So what is remaining is 2. And I'm almost out of room on my sticky note, but here you can see that 2 equals x. So those were just a few examples of how we can use those algebra tiles to help students understand different algebraic concepts. And the two that we really emphasized were using 0 pairs, and we also emphasized whatever you do to one side of the equal sign, you also have to do to the other side of the equal sign.